Next, some result we have to know, that is equal to e power I theta. So you have to differentiate. Dz is equal to I into e power I theta into d theta. So dz is equal to I into e power I theta can be written as z. So dz is equal to iz d theta. So d theta is equal to dz divided by iz. D theta is equal to dz divided by iz. What is z? Is equal to e power I theta. So z is equal to cos theta plus I sin theta. Take this equation number 1. 1 by z is equal to cos theta minus I sin theta. So take this equation number 2. So 1 plus 2. Equation number 1, equation number 2, you got to add. So z plus 1 by z is equal to 2 cos theta. So z square plus 1 divided by z is equal to 2 cos theta. So cos theta is equal to z square plus 1 divided by 2z. In the similar way, 1 minus 2. This gives z minus 1 by z, which is equal to 2i sin theta. So therefore, z square minus 1 divided by z, which is equal to 2i sin theta. So sin theta is equal to z square minus 1 divided by 2i z. So cos theta is equal to z square plus 1 divided by 2z. Sin theta is equal to z square minus 1 divided by 2i z. So these results we are going to we are going to use these results in while we are going to solve the contour integration problems. Contour integration is using contour integration evaluate integral over the limit 0 to 2 pi d theta divided by 5 minus 4 sin theta. So what is z e power I theta? What is a dz I into e power I theta into d theta? So dz is equal to iz d theta. Dz is equal to iz d theta. So d theta is equal to dz divided by iz. D theta is equal to dz divided by iz. Here the problem is integral over the limit is 0 to 2 pi d theta divided by 5 minus 4 sin theta. 5 minus 4 sin theta. So therefore sin theta already we know z square minus 1 divided by 2i z. Therefore the given problem can be written as integral over 0 to 2 pi d theta divided by 5 minus 4 sin theta is equal to integral over c dz divided by iz whole divided by 5 minus 4 into z square minus 1 divided by 2i z. 5 minus 4 into z square minus 1 divided by 2i z. So integral over c dz divided by iz whole divided by 10i z. If you are taking LCM, 10i z minus 4z square plus 4 divided by 2i z. So integral over c dz divided by I z into 2i z divided by minus 4z square plus 10i z plus 4. So 2i z divided by I z cancel. So answer is 2. So 2 into dz divided by minus 4 if you are taking common in the denominator, it will become as 2 dz divided by minus 4 into z square plus 10 divided by minus 4 iz plus 4 divided by minus 4. So minus 2 divided by 4 integral over c dz divided by z square minus 10 by 4 iz minus 1. So minus 2 by 4 is minus 1 by 2 integral over c dz divided by z square minus 5 by 2 iz minus 1. You can compare with the theorem integral over c f of z dz. So if you compare these two, integral over c f of z dz is equal to integral over c dz divided by z square minus 5 by 2 iz minus 1. So f of z is equal to 1 divided by z square minus 5y divided by 2 into z minus 1. This is f of z. We have to find the poles of zeros of z square minus 5 by 2 iz minus 1. For this, you have to find the poles. This is the quadratic equation. If the quadratic equation is given, you know very well how to solve the quadratic equation. Ax square plus bx plus c is equal to 0. This is the quadratic equation. The formula to find the solution for this quadratic equation is minus b plus or minus square root of b square minus 4ac whole divided by 2a. So minus b 5y divided by 2 plus or minus square root of b square 25 I square divided by 4 minus 4 a is 1 c is minus 1 whole divided by 2a. So 5y divided by 2 plus or minus square root of minus 25 divided by 4 plus 4. We are taking LCM. 5y divided by 2 plus or minus square root of minus 25 plus 16 divided by 4 whole divided by 2. So 5y divided by 2 plus or minus square root of minus 9 by 4 whole divided by 2. Therefore, 5y plus or minus 3i divided by 4. So 5y plus 3i divided by 4, 5y minus 3i divided by 4. So 8i by 4, 2i divided by 4, 2i comma I by 2. These are the solutions of poles of the equation of z square minus, you have seen, you have studied the equations, solutions. So 2i in the first type contour integration, always modulus z is equal to 1. What is modulus z is equal to 1? Modulus z is equal to 1 means the circle, unit circle. Unit circle means if you're taking the radius should be 1. So that is unit circle. 2i is the simple pole lie outside modulus z is equal to 1. 2i does not lie inside the modulus z is equal to 1 because every side there is 1, radius is 1. 2 is outside of radius 1. But I by 2, that is 1 by 2, 1 I by 1 divided by 2 I. 1 by 2. 1 by 2 is the simple pole lies inside the circle modulus z is equal to 1. So, which lies outside the circle, the value is 0. Which lies inside the circle, you have to find the residues. The residues at z is equal to I by 2. Residues at z is equal to I by 2. So, therefore, limit z tends to I by 2 into z minus I by 2 into f of z. So, limit z tends to I by 2, z minus I by 2 into f of z is equal to 1 divided by z minus 2i, z minus I by 2. So, z minus I by 2 divided by z minus I by 2 cancel. So, limit z tends to I by 2, 1 divided by z minus 2i. So 1 divided by I by 2 minus 2i. So 1 divided by I minus 4i divided by 2, which is equal to 1 divided by minus 3i by 2, which is equal to minus 2 divided by 3i. Minus 2 divided by 3i. This is the answer. For residue, z is equal to I by 2. Next, hence, by residue theorem, integral over C f of z dz is equal to 2 pi I into sum of all residues, which is equal to 2 pi I into sum of all residues are minus 2 divided by 3i. I cancel, minus 4 pi divided by 3. But from equation number 1, integral over the limit 0 to 2 pi d theta divided by 5 minus 4 sine theta, which is equal to minus 1 by 2 integral over C dz divided by z square minus 5 by 2 iz minus 1. This minus 1 by 2 for integral over C dz divided by z square minus 5 by 2 iz minus 1. You can write as minus 4 by 4 pi divided by 3. So integral over the limit 0 to 2 pi d theta divided by 5 minus 4 sine theta, which is equal to 2 pi divided by 3. Okay, this is also very important problem. One more important problem is using contour integration. Integral over the limit 0 to infinity dx divided by x square plus 1 minus infinity to plus infinity. Integral over the limit minus infinity to plus infinity dx divided by x square plus 1, which is equal to 2 into integral over the limit 0 to infinity dx divided by x square plus 1. But here 0 to infinity, the limit is 0 to infinity. So integral, the limit is 0 to infinity dx divided by x square plus 1. For this also you can find, which is equal to 1 by 2 integral minus infinity to plus infinity dx divided by x square plus 1. Take this equation number 1. If you want to find the value of the contour integration for integral over the limit 0 to infinity dx divided by x square plus 1, which is equal to 1 by 2 integral minus infinity to plus infinity 1 by 2 integral minus infinity to plus infinity dx divided by x square plus 1. So we have to find the value of integral minus infinity to plus infinity dx divided by x square plus 1. Here f of z is equal to 1 divided by z square plus 1. Consider integral over c f of z dz is equal to integral over c dz divided by z square plus 1, where c is the upper half of the semicircle gamma with being with bounding diameter is minus r to plus r. This minus r to plus r, that is a real line, minus infinity to plus infinity. By Cauchy's residue theorem, we have integral over c f of z dz is equal to integral over minus r to plus r f of x dx plus integral over the limit gamma f of z dz. The pole of f of z are the solutions of z square plus 1 is equal to 0, the denominator. So z square is equal to minus 1, z is equal to plus or minus I. Here z is equal to I is a simple pole, lies inside gamma. Z equal to minus I lies outside gamma. So residues at z is equal to I, which is equal to limit z tends to I, z minus I into f of z. So limit z tends to I, z minus I, f of z is 1 divided by z square plus 1. So limit z tends to I, z minus I, 1 divided by z square plus 1 can be written as z plus I into z minus I. Z minus I divided by z minus I cancel. So 1 divided by I plus I, which is equal to 1 divided by 2I. Hence, by Cauchy's residue theorem, integral over C f of z dz is equal to 2 pi I into sum of all residues. So 2 pi I into 1 divided by 2I. So 2I divided by 2I cancel. So pi. So integral over minus r to plus r, f of x dx is equal to plus integral gamma f of z dz is equal to pi. If r tends to infinity, then integral over gamma f of z dz tends to 0. That is integral over minus r infinity to plus infinity. F of x dx is equal to pi. Equation number 1 becomes integral over the limit 0 to infinity dx divided by x square plus 1 is equal to 1 by 2 into integral over the limit minus infinity to plus infinity. F of x dx, which is equal to 1 by infinity 1 by 2 integral over the limit minus infinity to plus infinity dx divided by x square plus 1 is equal to pi by 2. So this is the answer. So here you have to listen these two. There are two things are very important. One is the contour integration. There are two methods. One is integral over the limit 0 to 2 pi f of theta d theta. In the unit circle, modulus z is equal to 1. This is one of the method. Another method is only upper semicircle you have to find. Minus integral over the limit minus infinity to plus infinity f of x dx. Here, only you have to find the upper semicircle. Lower semicircle we will never consider. These are the two big difference in the type 1, type 2 in contour integration. Okay. So remaining things will be easy. But the two things you have to keep in our mind. First one is minus infinity to plus infinity. This is type 2. Minus infinity to plus infinity is given. No problem. Directly we can solve. But 0 to infinity is given. You have to write integral over the limit 0 to infinity f of x dx is equal to 1 by 2 integral minus infinity to plus infinity f of x dx. So if you want to find the value of integral over the limit 0 to infinity f of x dx, first you have to find the value of integral over the limit minus infinity to plus infinity f of x dx half into. So you can find only the value of minus infinity to plus infinity f of x dx. After finding the value, final result, if you multiply with 1 by 2, you will get the value of integral over 0 to infinity f of x dx. This is very important. This is one of the things. Other thing is integral 0 to 2 pi f of theta d theta, which is equal to, sometimes it may be given. Find the value integral over the limit 0 to pi f of theta d theta. How to find? We know only integral over the limit 0 to pi f of theta d theta is equal to 1 by 2 into integral 0 to 2 pi f of theta d theta. So after finding the value of integral over the limit 0 to 2 pi f of theta d theta, then multiply with 1 by 2, you will get the original integral over the limit 0 to pi f of theta d theta value. Okay. So two things are very important. Whatever is given, you have to change to integral over the limit 0 to 2 pi f of theta d theta. Only you can solve this one. Why we are taking 0 to 2 pi? 360 degree. In this way, minus infinity to plus infinity is important. 0 to infinity is given. You have to change it to 1 by 2 into integral over the limit minus infinity to plus infinity. Then only you can solve. Otherwise, you will be unable to solve. Okay. So thank you all.